Hey kiddos. Today we're going to finish up this unit that you are testing on next week, and we're going to talk about accumulation functions. So what we are about to analyze is this function f of x, and it is defined as the integral from 5 to x of this curve that you're looking at. So they could ask you a couple different things. We're just gonna dive right in, and everything is function notation. So if they asked me to go find f of 9, for example, then all I'm doing is function notation. So x got replaced with 9, so we're going to go replace x with 9. And now it's the integral from 5 to 9 of g. Okay, well, don't let this upset you. We've done this. So if I start at 5 and I stop at 9, how much area have I accumulated is the question. So I'm going to treat this like a trapezoid. If you want to do a rectangle and a triangle, that's fine. But my trapezoid is 1/2. Its height is 4. And its bases are 6 plus 3. So that would be 2 times 9 is 18. The end. They could ask me to do a couple different things here. Like they could ask for f of 1. And then I would be taking the integral from 5 to 1 of g. Again, no panicking. Let me do this in a different color. So this one's in red. This time I'm starting at 5 and I'm going backwards to 1. That's okay. We've done this. So if I'm moving backwards to 1, but my height values are still positive, this is going to have a negative accumulation. So I'm just going to do this rectangle with a base of 4 and a height of 6. I get 24 pretty quick. That's easy enough. But what happens when they start to ask more exciting things like, what if they ask me for f prime of 3? All right, so these inputs that I'm picking, like this 9 and the 1, the 3, that's completely random. I'm just making stuff up. So here's the big takeaway for today. So this is kind of tying everything up with just a beautiful bow. Here's what they gave you. They told you that this was true. Now we're going to go do this wonderful thing called the fundamental theorem of calculus to go figure out what it means about f prime. So if f is the integral of g, f prime is g. That's what we learned about with fundamental theorem, that a derivative undoes the integral. So, all right, if I differentiate both sides, f turns to f prime, integral g turns to g. If I want a second derivative of f, I would differentiate both sides again. This would be g prime. This is the magical notes that you should put on every single one of these questions. Every time I start one of these questions, I write this first. Now, the notation is terrible, and that's okay because it's just like something for me to look back on, work off to the side so that I know I'm doing okay. But now that I have that, I don't have to think very much. So pay attention to the fact that this is a graph of G, and now I'm going to use my notes up there. They're asking me for f prime of 3. Well, that's going to be the same thing as g of 3. Well, this is a graph of g, so if I go to 3, my function value there is 6, the end. If they want a second derivative, I'm not going to let me use a different number, like -3. Then I'm going to use my notes again up here, f double prime. This would be g prime of -3. So if this is a graph of g, and then I need to go find g prime, I have to go find the slope here at -3. Let me see, am I smart enough to do this slope quickly? Probably not. That's okay. I think I'll count a rise and a run. So this is going to rise 9, and this is going to run 6. So I get 3/2 as that slope. I just went from dot to dot. You could have done some ones in between, but that's what we're doing. So that's it for today. That's it. That's all the practice you're going to have in Delta is evaluating accumulation functions in different places. Where this is headed is now I can ask you all that vocabulary back from Unit 5 is going to come back. And now they're going to ask, where does F have a rel min. And now you have to go back to all of your vocabulary. So they want f to have a rel min. Well, I know the definition of a relative min is when f prime, its derivative, changes from negative to positive. Okay, so now if I go back up and use my notes again, so if f prime is changing negative to positive, then I need g to change negative to positive. And that looks like that happens, here at -3. So at x equals -3. That's where this is headed. All of that vocabulary is coming back, but inside of integrals. That's it. Let me know if you need anything.